I also changed the pixel aspect ratio to 1 and I cached it. And I play this, you'll notice that the camera has what we call a nodal pan movement. What exactly is a nodal pan movement? As you can see in this illustration, a nodal pan movement is a stationary camera that does not translate on all three axes, but rather than that, it rotates on one axis, either X, Y, or Z. And also notice that the camera is not rotating around the center of the lens, rather than that, it's rotating around the center of the tripod, which forces the film gate to have an arch in its rotation, as you can see in this illustration. So how do we approach such a shot in PF-Track? Well, the first thing we have to do is to figure out what is the lens here. And also, we are going to use the automatic tracking node. In order to figure out what is the lens, I'm going to click on Create, and I'm going to call this Estimate Focal node. And in this node, I'll be able to figure out what is the focal length. And the focal length is the distance between the center of the lens to the film gate. So I'm going to put the footage at the end right here. In this node parameters, I'm going to deactivate the ground. And with these lines, these X lines, because I have the X here, I'll be able to define where exactly is the direction of X. Now I have this line here, right over there, and I have this X line right here. So you're just making sure it follows. And right here in the middle, notice that I get the vanishing point. Now let me take this line and just make sure that it follows. That's good. I can also determine where the Z is, and the Z is always opposite to the X. So let me deactivate right here the X and activate the Z axis. I'm just matching up the Z lines right over here, and right over here we have this definition here of the building. And PF-Track has determined that the lens that I have is almost 60 millimeter. Now I'm going back to the Create, and I'm gonna call the Auto Track, and in the Auto Track I'm going to define the deformation, just the rotation, and I'm going to change this to better accuracy. And the consistency is not a free camera anymore, it actually just rotation only, which means PF-Track will know that at this point the camera does not translate in 3D space, but just rotates around one of the axes. If I look at the footage again, I see that I have a few things here that move. First of all, I got a few leaves that move. It was somewhat of a breezy day when I shot this. And I also have the fountains going on here in the distance. So I want to mask the fountains out. And that would be by the use of a mask. Now the mask is only available once you work in the Auto Track node. So I'm going to the mask right here, and I'm going to click on Roto, and I'm going to draw a garbage mat around these fountains. Now PF-Track has the ability to make this mask follow whatever pattern it is. I started off somewhere around here, and I'm going to this button right here, and this is the track selected mask backwards, and PF-Track is going to follow that shape. I'm going back to my initial keyframe for that mask, and I'm going to track it forward. And these fountains now will start to disappear, and I've stopped my auto tracking with just the masks, and I'm going to make sure that my mask will be moved manually until I don't see these fountains completely. There's another one over here. I kind of missed it. Okay, let's make sure that the previous frame is also covering that. That looks good. And right around here, those fountains disappear. So I'm going to take this point. It's very similar to rotoscoping processes in Nuke or After Effects. The frame that these fountains disappears is 425. So I'm going here to the out point, 425. I'm going to click on the out, and the mask will stop here at that specific frame. Great. I'm going back to the parameters, and I'm going to make sure that I click on the auto track. I'm going to stop the video here, and I'm going to let the software auto track this sequence. The automatic tracker, as you can see, did not put any trackers inside the mask area, but it created trackers where the software see a lot of contrast, especially in color and gray levels. Now I'm looking very carefully around the trees. The software have decided to put some trackers on the trees, and I want to make sure that even though it was a windy day, I want to make sure that the trackers on the trees are not moving too much. The reason that we don't put trackers on moving objects, because then it's going to create some sort of a noise in the camera. So while I'm here in the auto track. I'm going to take my marquee tool. I'm going to choose these 3 trackers, click, drag, and release. And right here under the marquee tool, there's a delete button. So I'm going to click on delete. The software is going to, are you sure you want to delete these three 2D trackers? I say yes. Now I'm going to call the camera solver. In the camera solver, the camera was not moving on X, Y, and Z, but just rotating around the Y axis. Under here, the translation, I'm going to open up this pop menu and say none. The translation is not going to be calculated at all. And yet again, the rotation is going to be high smooth. And then what I'm going to do is I'm going to click on solve all. So I got a solution. I would like to show you how the 3D space looks right now. So if you remember from the beginning of the lecture, I told you about the rotation that the film gate is going through around the center of the tripod. When the computer calculates a nodal pen shot, it is actually calculating a very unique point cloud. This point cloud of 3D trackers actually simulates the rotation of the film gate, and it's not representing the real 3D world. Well, that's a problem. If it does not represent the true 3D world, then how can I set fit this? At this point, I can select a tracker that was on the ground, for example, this tracker here, by choosing the orient scene. And I'm going to take in the orient scene parameters my marquee tool, select this tracker, and say set origin. Now I can go ahead and rotate. Just rotate here. And of course, I'm going to rotate on the Y, just a tad on the Z. Not too much. All right, that's pretty good. I'm kind of matching the horizontal line to the line of windows that I have on this building right here. In Maya, there's a high chance that I'm going to re-rotate this group and reposition it. Probably I can continue to rotate this on the Z just a tad. That is actually not on that window, but here on the edge of this wall. I'm going to the export, and I'm going to export this into a Maya file. So I went ahead and opened up this file in Maya, and here is my group trackers. I'm going to select the camera. Now I'm going to change everything that we have talked about. Far clip, give it a number with a lot of zeros behind it. And I'm going to change the fit resolution gate to horizontal, going to the image plane, and then changing my image plane to look through the camera. And of course, this is going to be only RGB. And I'm going to change the depth, which means the distance of the image plane from the camera, to 50,000. There we go. Before I continue forward, I would like to show the animation graph editors of this camera. I'm going to Window, Animation Editors, Graph Editor, and notice that the Translate X, Translate Y, and Translate Z have no animation on them. Yes, there are keyframes, but they all have the same value. But Rotate X have a really nice graph on it, as well as Rotate Y, but Rotate Z unfortunately has a huge jump in it. This is probably because of some noise. So what I can do is I can select these keyframes, I can snap these guys back to where they belong. Let me just zoom into this. There. Now I can switch back to my quad view, go to my camera, and in the camera I can eliminate the grid, click on the film gate. The question is, if these trackers do not represent true 3D space, how can I rely on these trackers in order to build proxy geometry? What I can do is start building at least part of the geometry and continue forward with the geometry, only relying on what I see through the camera. And that is because, yet again, I cannot rely on this point cloud. So I'm going to start off with a box, and I can take my box and make sure that it's close to the center of my scene. And I can select the whole group. Now, what I did here is I put the coordinate system right on this corner. So I can take the grouped camera and snap it to that corner of my proxy geometry. And I'm also going to change the coordinate system of the cube to that specific corner right there. Now you can see that the cube is rather small in the 3D space, but through the camera it looks very big. So I can select my whole group, and by changing the scale on all 3 axes simultaneously, so it will fit better with my box here. Now I'm going to match by looking at my footage and comparing it to the cube that I have in 3D space until I get the right perspective. Rotation is needed, and I'm going to try to find the right perspective for my group. Okay, so I see now that I can rescale my box right over here. Now let me just double check. It needs to be scaled a little bit further, and the group needs to be rotated just a tad towards the right. So let me rotate the group first, and just a tad on the Y. Yeah, that looks good. Now I'm going to scroll around to make sure that my geometry stays true to the footage. Great. I can continue to build my scene here. I can take a plane and create the floor, just like that. Let's see, maybe over here. And I can move this back, and I can take my scale tool and scale my floor. In the next video, we're going to talk about